Hello everyone, this is MD Jahangir Hussain, and today I'm going to solve Cambridge S and A level P1 May June 23 variant 12. Okay, this is May June 23 variant 12. So that's P1. And in question 1, you see the equation of the curve is given is such that dy by dx equal to 4 by x minus 3 whole cube for x greater than 3. The curve passes through the point 4, 5. Find the equation of the curve. Here we have the gradient of the curve. Now we have to find the equation of the curve. dy by dx, that's the gradient. That's gradient. Now we have to find the equation of the curve. So from the gradient, if you want to find the equation, you have to integrate the gradient, which is 4 by x minus 3 whole cube. Let's bring x minus 3 on the numerator, so the power will be negative dx. So to integrate this one, remember the formula. If we integrate linear function of x to the power n, result will be power increases by 1 divided by new power, and you have to further divide by the coefficient of x. So that's the integration of this. So you apply this one here. Therefore, y becomes 4 x minus 3 whole to the power minus 3 plus 1, that's minus 2 divided by minus 2, and coefficient of x is 1, yeah, plus constant of integration. So we have this one, minus 2 divided by x minus 3 whole square plus 3. Now, to find the constant c, use the boundary condition that this curve passes through the point 4, 5. So if you substitute y equal to 5, x equal to 4, in this equation we have c equal to 5 plus 2, that's 7. The equation of the curve will be y equal to 7 minus 2 by x minus 3 whole square. That's question number 1. And now let's move to question number 2. In question 2, you see, you have to, let's read the question first. The coefficient of x to the power 4 in the expansion of x plus a whole to the power 6 is p, and the coefficient of x square in the expansion of x plus p whole to the power 4 is q. It's given that p plus q is 276. Find the possible values of the constant a. Now here, you can use the general term of a binomial expansion or the whole expansion. I'm using here the whole expansion, and the formula for binomial expansion is a plus b whole to the power n is a to the power n nc1 a to the power n minus 1 into b plus nc2 a to the power n minus 2 b square. Okay. Now we need the expansion of both the binomial. Let's rearrange the binomial using write the constant first and x second, a plus x whole to the power 6. And in this expansion, we need the coefficient of x to the power 4. So why not we use the basic one, the given one? Let's use the given one where the binomial is x plus a whole to the power 6. Hence, we use the coefficient of x to the power 4. Apply it here, the binomial expansion formula, x to the power 6 plus 6, 3, 1, x to the power 6 minus 1, 5 into a. We'll need the next term, which is 62. And in this term, we'll have the coefficient of a power of x is 4. 4 a square. We don't need any further term. So the coefficient of x to the power 4 in the expansion of x plus a whole to the power 6 is 62 a to the a square. And then we need the coefficient of x square in the expansion of the next binomial, which is ax plus b whole to the power 4. We need the coefficient of x square. So the first term, x whole to the power 4, then 4c1 x to the power 4 minus 1, that's 3, into 3 plus 3 to the power 1, plus 4c2 x whole to the power 4 minus 2, that's 2, into 3 square. So you see the coefficient of x square here is 4c2 a square into 3 square. And coefficient of x square in the first one, we need the coefficient of x to the power 4 in the first expansion. Coefficient of x to the power 4 is 62 a square. And in the second expansion, we need the coefficient of x square, which will be 4c2 a square into 3 square, that's 9. Now, this is Q, and that is P. And remember, P plus Q equal to 276. So use this one, P plus Q, 276 is 62 a square, and here we have 4c2 now into 9a square, 276. 6c2 is 15 a square, 4c2 is 6 into 9, 6 into 9. How much is that? That is 6 into 9 is 54 a square, 276. From this one, we have 6, 9, 69 a square equal to 276. So a square equal to 276 divided by 4. That's divided by 16. So 276 divided by 69 is 4. So a is plus or minus 2. A can be either positive or negative, both. Okay. So this is question number 2. Now let's move forward to question number 3. In question 3, you see, express this one into express 4x square minus 24x plus b in the form a into x plus b whole square plus c, where a and b are integers and c is to be given in terms of the constant p. So you need to do the completing square here. To do the completing square, first you have to take 4 common from x square and x only. Only 4 common because we're going to complete the square. So we'll take only 4 common from x square and x. So we have this one. Why are we are taking only 4 common? Because the question is asking for data, this, and we'll use the completing square formula here. To use the completing square formula, we need the expansion, the expression in this form. Remember the formula for completing a square, x square minus bx. If you have x square minus bx, you can use directly this formula to complete the square. X minus b by 2 whole square minus b by 2 whole square. So here we need x square and x. That's why we took only 4 common from x square and x, not for x. Now, if you complete the square here, we have x minus b by 2. You see, b is here 6, so 6 by 2, that's 3, b square, minus b square, b by 2 whole square, that's 3 square, and that close plus b. Now, simplify 4 into x minus 3 whole square, minus 4 into 9, that's 36 plus b. So, we have 4 into x minus 3 whole square plus b minus 36. So, A is 4, B is minus 3, and C is B minus 36. That's part A. Now let's move on to part B. In part B, you have to hence or otherwise, find the set of values of P for which the equation has no real root. The equation has no real root, and you can use the results from part A, or you can do it otherwise. If we use the result of part A, in part A, we have completed the square. So if we directly use it, 4 into x minus 3 whole square plus p minus 36, this is equal to 0. So 4 into x minus 3 whole square equal to 36 minus p. Now, this equation will, what we have to find the set of values of p for which the equation has no real roots. The equation will not have any real roots if the right-hand side in the second line is negative. Okay. If the right-hand side is negative, then what happens? If it is negative, then the square of a number is always a positive number. Square of a real number is always positive. Since this equation has no real root, so this square will be negative. So you can directly say it, since there is no real root, so 36 minus p less than 0. So p is greater than 36. That's the set of values of p. That's B, part B of question number 2. Let's go to question number 3 then. That's part B of question number 3, my bad. Let's move to question number 4. In question number 4, you have to solve this equation, which has highest power of 6. But look at the power. The highest power is 6, then the next term has power of 3, then the next term is a constant. So this equation is in this form. A x to the power twice n plus b x to the power n plus c equal to 0. You know, if the equation is of this form, you can use it as a quadratic and use the middle term bracket to factorize. Okay, so to make it as a quadratic expression, let's first substitute x to the power n, which is here x cubed. Let x cubed to be equal to y. So in that case, the equation becomes 8y square plus 215y minus 27 equal to 0. Now use the direct formula to solve the quadratic, or you can use the middle term break as well. If you do the middle term break here, the middle term will be 216y minus y minus 27. So we take hy common from the first one, y plus 27, and minus 1 from the next two term, y plus 27. So we have y plus 27 into 8y minus 1 equal to 0. So y is either minus 27 or y equal to 1 by 8. Nice. Now, back substitute y, which is equal to x cube. So x cube equal to minus 27. X equal to cubic root of minus 27, that's minus 3. X cube equal to 1 by 8. So x is half. So these are the solution. These are the root of this equation, minus 3 and half. That's question number 4. Now let's move forward to question number 5. Question number 5, see here, the diagram shows the curve with equation of y equal to 10 x to the power half minus 5 by 2 times x to the power 3 by 2 for positive x. The curve meets the x-axis at the point 0, 0 and 4, 0 to find the area of the shaded region. So here we are actually finding the area enclosed between curve and x-axis. And the limits are 0 and 4. And you know, area between curve and x-axis is given by area equal to integration of y dx. Here, the lower limit of x and the upper limit of x. So that's how we find the area between curve and x-axis. So let's do it. Area will be equal to lower limit of x is 0, upper limit of x is 4. And the equation of the curve y in terms of x, it is 10 x to the power half minus 5 by 2 x to the power 3 by 2 dx. Now, to do the integration, remember integration of x to the power n is x to the power n plus 1 divided by n plus 1 plus 3. Here we have the limit, so we'll not give plus 3. Direct do the integration first. X to the half plus 1, that is 3 by 2 divided by 3 by 2 minus 5 by 2 times to the power 5 by 2. 3 by 2 plus 1, that's 5 by 2 divided by 5 by 2. That's the integration. Now, since we have limit, we put a third bracket and place the limit at the end of the bracket. Now, to simplify, this is 20 by 3 into 4 to the power 3 by 2 minus 5 by 2 here, 5 by 2 and 5 by 2 divided by 5 by 2 cancels out. So we have only x to the power 5 by 2, that is minus 4 to the power 5 by 2. We have substituted the upper limit, now substitute the lower limit. Since the lower limit is 0 and there are only x, no constant, no other expression, so it will be 0. Now calculate 160 by 3 minus, that is 32 minus 32. So this is 64 by unit square. That's the answer in improper fraction. You can write it as a mixed fraction, mixed form, or then write it in 3SF correct to 1 decimal. Okay, that's question number 5. Let's move on to question number 6 then. Question number 6, you see, yeah, the diagram shows the sector OAB of a circle with center O, the angle AOB, theta radian OP equal to AP equal to X, so that the arc length AB is 2x theta cos theta. Now, to find the arc length, remember arc length is theta r, right? Arc length equal to theta into r, where theta is measured in radians. And here in this sector, the radius is OA or OB, which is unknown here. You only know OP and AP, both of them equal to X. So if you consider the triangle OAP, you can find OA and main in various ways. The most common one is using cosine rule, and the shortest one will be, since it is an isosceles triangle, so if we draw a perpendicular from P onto OA, that will bisect it because it is an isosceles triangle. Now, from the triangle OPM, you see, you can uh, use the ratio OM by OP, which is P cos theta. So OM equal to OP into cos theta. OP is X, so it is X cos theta. Then AB is double of OM, not AB, this is OB, which is the radius. My bad. OA, which is the radius, which will be double of OM. OM is X cos theta, so this is 2X cos theta. Now we see the arc AB equal to R into theta. R is OA, 2X cos theta into theta. So this is 2X theta cos theta, where theta is in radian. That's the arc length of AB. Now, in part B, you have to find the area of the shaded region, APB. Okay, to find the shaded region, and you will find the area of the shaded region in terms of x and theta. And to find this area, you see if you can find the area of the sector minus area of this triangle OAP, will get the area of the shaded region. So, the area of the shaded region, area of sector minus area of the triangle OAP. Area of the sector, to find the area of the sector, half r squared. Remember, area of the sector is half r squared theta. Area of shaded region, sector OAB minus triangle OAP. And sector area, remember, sector area is half r squared theta. R for this sector is 2x cos theta. Okay? Let's write down the formula first. Half r squared theta minus the area of the triangle OAP. To find the area of the triangle, you need this angle OPA because we know the length x and AP, or you can also use the half OA into OP into sin theta. Either way, we are following here the second one, half OA into OP to sin theta. So, this sector area, for this sector area, the value of R is 2x cos theta square into theta minus half into OA, which is 2x cos theta into OP, which is x into sin theta. So we have 2x square cos square theta into theta, and here we have x square sin theta cos theta. So if we take x square cos theta common, we have 2 theta cos theta minus sin theta. That's the area of the shaded region in terms of x and theta. Okay, that's part B. Is there any part of this question remaining? No. Okay, that's question number 6. Let's move on to question number 7 then. In question 7, we have by first 7a1. By first expanding cos theta plus sin theta whole square, find the three solutions. They have mentioned the number of solutions. So you have to give exactly three solutions of this equation. Of the equation cos theta plus sin theta whole square equal to 1 or theta 0 between 0 and pi inclusive. Now, let's follow the instruction of the question. First, you need to expand this one. Cos theta plus sin theta whole square, so it will be, we are using a plus b whole square here. A plus b whole square, remember the function of this a square plus 2ab plus b square. So, we have cos square theta plus 2 cos theta sin theta plus sin square theta equal to 1. Now, you know the identity involving cos and sine, the Pythagorean identity, cos square theta plus sin square theta, which is equal to 1. So if we apply this cos square theta plus sin square theta, the left hand side equal to 1. So the equation becomes 1 plus 2 cos theta plus into sin theta, and bring that 1 from the right hand side to the left hand side. So we have the final equation 2 cos theta sin theta equal to 0. So either we have two different sets here, either cos theta equal to 0 or sin theta equal to 0. Now cos theta equal to 0, when it occurs, cos theta can be 0, and remember the graph. We can solve the equation cos theta equal to 0 using the graph of cos theta or using basic equation. Both. If you consider the graph, we can write it directly. If you consider the graph of cos theta y equal to cos theta, you see cos theta crosses the x-axis at pi by 2, 3 pi by 2. Since we have the limit of theta between 0 and pi, so there is only one value. So theta equal to pi by 2. You can solve it a different way as well. And if you consider the graph of sin theta or positive theta only, this is the graph. And sin theta is 0 at 0, pi, and 2 pi. We have the limit here between 0 and pi inclusive, so we will get two values of theta here. It is 0 and pi. You can also find the solution of theta using basic exercise. I'm sure using the graph here, since cos theta and sin theta both equal to 0. So we have three values of theta, 0, pi by 2, and pi, for which this equation holds true. Okay, that's part A1. Now let's move to part A2. Hence, verify the only solution of this equation for theta. For theta between 0 and pi are 0 and pi by 2. Although we have the solution of the equation, the equation cos theta plus sin theta whole square equal to 1. In fact, this one has three different solutions, 0, pi by 2, and pi. But for this one, if you remove the square, see, we have in fact two different equations. If you remove the square, you have to do the square root. On the right hand side, we'll have plus and minus. So this the value of theta for the first equation are not all the solutions. So few of them, the solution of tan theta plus cos theta equal to 1, and one or two of them will be the solution of the other one. And which one? You have to verify that theta equal to 0 and pi by 2 are the solution of this equation. How can I verify it? You simply substitute in theta equal to 0. What happens to the value of cos 0 plus sin 0? Is it equal to 1? Cos 0 is 1, sin 0 is 0, so this is 1. When theta equal to pi by 2, cos pi by 2 is 0, sin pi by 2 is 1. So 0 plus 1, that's equal to 0. So both of them verify the equation. What happens when you substitute theta equal to pi? Cos pi is minus 1, sin pi, so that is minus 1. Does not verify. So theta equal to pi is not the solution of cos theta plus sin theta equal to 1. The only solution are 0 and pi. Verify. Okay. Is there any other part? Or there should be part B of this question 7. So let's move on to part B. Part B, you have to prove the identity. Okay. This left hand side equal to right hand side. You see, right hand side is more complicated. So let's start with the left hand. Here we have two different expressions. We have two different fractions. We'll convert it into single fraction on the left hand side. So directly do the LCM. Cos theta plus sin theta. Since the denominator are different, so LCM will be product of these two denominators. Now we have to multiply sin theta with the denominator of the second fraction, cos theta minus sin theta, and 1 minus cos theta with the denominator of the first fraction, cos theta plus sin theta. Then we have to multiply. We will find it sin theta into cos theta, sin theta cos theta minus sin theta into sin theta, that's sin squared theta. And the second one we have cos theta plus sin theta minus cos squared theta minus sin theta cos theta. Okay. And the denominator we have cos theta plus sin theta into cos theta minus sin theta. So we can consider it. This, if this is A, this is B, then this is A minus A plus B into A minus B. Remember, A plus B into A minus B equal to A square, that is B square. So you can apply it here. So it becomes cos square theta, cos theta whole square, that's cos square theta minus sin theta whole square, that's sin square theta. And if you look at the numerator we have plus sin theta cos theta and minus sin theta cos theta. These two cancel out each other. And we have here cos theta plus sin theta and minus sin square plus minus cos square. If you take minus common from these two, we have sin square theta plus cos square theta. And this is another the Pythagorean identity here, because sin square plus cos square is equal to 1. And in the denominator, you see on the right hand side, you have to show 1 minus 2 sin square theta. So you have to convert the cos square theta in the denominator into sin theta. So we can write it, this cos square theta, convert it into sin square theta. And the Pythagorean identity we are using here, sin square theta plus cos square theta equal to 1. So the denominator cos square will be 1 minus sin square. So the expression is, in the numerator we have cos theta plus sin theta minus 1. In the denominator we have 1 minus 2 sin square theta. That's the right hand side. So, okay, guys, uh, let's move on to the next part, part C. In part C, using the result of A2 and B, solve this equation. You have to use the result of A2 and B here. If you do not use the result of A2 and B here, you'll not get the marks. Since there is no other option available. So you have to use the result of A2 and B. To do that, remember, in part B, we have shown this left-hand side of this equation equal to this one, cos theta plus sin theta minus 1 divided by 1 minus 2 sin square theta. So we are directly using it. The left-hand side becomes cos theta plus sin theta minus 1 divided by 1 minus 2 sin square theta. The right-hand side is change. So what we have here on the left-hand side, if you do the cross multiplication here, cos theta plus sin theta minus 1 equal to 2 times cos theta plus sin theta minus 1 into 1 minus 2 sin square theta. Now bring all the term on the left-hand side. Let's multiply this 2 with the second one, 1 minus 2 sin squared theta, so that it becomes 2 minus 4 sin equal to 0. So now we can take cos theta plus sin theta minus 1 common from these two equations. If we take common, it will be 1 minus 2 plus 4 sin theta. Right? So we have two different sets, 4 sin squared theta minus 1 and cos theta plus sin theta minus 1 equal to 0. And in part A2, we already know that cos theta plus sin theta equal to 1 has two solutions in this given interval, 0 and 5. So we are using that one here. So we have cos theta plus sin theta minus 1 equal to 0. That is cos theta plus sin theta equal to 1. So the solution of this equation is 0, 5. And we have another set here, 4 sin squared theta minus 1 equal to 0. So sin squared theta equal to 1 by 4. So sin theta equal to plus minus half. Let's try to go step by step. 4 sin squared theta equal to 1. So sin theta equal to plus minus half. And the interval is 0 to 5. So in this two, sign is positive. So negative is not working here, although sin theta can be minus half, but we do not get any value of theta for this because sin is negative in the third and fourth quadrant, and third and fourth quadrant is not included here. Here, the basic acute angle for sin theta equal to half will be sin inverse half, that's 30 degree in radians, that's pi by 6. So theta can be in the first quadrant. Quadrant we have theta equal to alpha. The secant angle pi by 6. In the second quadrant we have pi minus alpha, which is pi minus pi by 6. So we have two possible value of theta here, pi by 6, pi by 6. So we have overall 2 from the first one and from the second one. So in fact we have 4 values of theta, 0, if you write it in ascending order, 0, pi by 6, then we have pi by 2, and pi by 6. These are the 4 values of theta to satisfy this equation. That's it. That's part C of this question. Now let's move on to the next question. Next question is question 8. Here we have a graph of y equal to fx, where the function f is defined by b plus 2 sine x by 4, where x is between 0 and 2 pi. On the diagram above, you have to sketch y equal to f inverse x. To sketch the y equal to f inverse x, you have to reflect the diagram, the y equal to x line. If you mark the y equal to x line here, y equal to x line is this one, right? Yeah, this is y equal to x line. Now, we will reflect y equal to fx graph in this line to get the y equal to f inverse x graph. Now, there is another alternative. Since this curve has the y-intercept here, now what is the y-intercept? 0, 3. 0, 3 for y equal to fx. And this point has the coordinate, x coordinate equal to 2 pi. And what about the y coordinate? If you substitute x coordinate to be 2 pi, you see y is 5. So 5, 2 pi comma 5. Now, in the inverse function, the coordinate will interchange. For this 0, 3, for inverse function, it will be 3, 0. So 3, 0 is here, 3, 0. And for this 2 pi 5, it will be 5, 2 pi. 5, 2 pi, 5, 2 pi is here. Huh? 2 pi. Oh, and this is the intersection. So use this one. For the graph. Okay? That is the graph of y equal to f inverse x. Just reflect the graph of y equal to fx on the y equal to x line. This is y equal to x line. That is y equal to f inverse x. Okay, that's part A. Now let's move on to part B. Part B, you have to find an expression for f inverse x. For f inverse x, the expression will be, before we move on to part B, if you look at the graph of y equal to fx, what is the range of fx? Here you see the range is, the least value is 3 and greatest value is 5. So 3 to 5 inclusive. That's the range of y equal to fx, which will be the domain of f inverse x. Okay, for a y equal to f inverse x, to find the expression, what we do is simply make x the subject from y equal to fx. So y equal to a plus 2 sine x by 4. From this one, make x the subject. To make x the subject, to make 2 sine x by 4 subject first, y minus 3. Then we have sine x by 4 equal to y minus 3 by 2. Then x by 4 equal to sine inverse y minus 3 by 2. Then x is 4 sine inverse y minus 3 by 2. So f inverse x is 4 sine inverse x minus 3 by 2. So simply substitute the y on the right hand side by x and the x on the left hand side substituted by f inverse. So that's the expression for f inverse x, and the set of values of x here will be the set of values of y for the main function, which is 3 to 5 inclusive. And that's part B. Now, let's see what is in the next part. Okay? And the next part, okay, we have the graph, same graph again. The diagram above shows part of the graph of the function. Here, the difference is the domain has 10 set of values of x has 10. The first, the first graph. This graph is drawn for 0 to pi, 0 to 2 pi, but we have to complete the graph from for minus 2 pi to 0. So what is happening here? Let's see. We had the maximum point here. We have to find sine graph. There is maximum, and for sine graph there is maximum point and minimum point. What happens when x is minus 2 pi? If you substitute x equal to minus 2 pi here, what happens? X equal to, if you substitute minus 2 pi, then g minus 2 pi becomes 3 plus 2 sine minus 2 pi by 4, that's minus pi by 2. So it is 1. So at minus 2 pi, point is 1. Uh, where will be 1? I think this is pi by 4. So pi by 4 is slightly less than, or that is 0.785. So 1 will be somewhere here. And that will be maximum curve. So if you like, and now if you are confused about the direction, what do you see? If you consider the curve of sine x by 4. If you remember, y equal to sine x curve, y equal to sine x curve is, if you know the y equal to sine x curve from that one, you can draw the y equal to sine x by 4. Sine x curve is minus from sine x curve here, the domain is, for the second one, domain is minus 2 pi to plus 2 pi. And the first one, corresponding domain is minus pi by 2 to plus pi by 2. Because why this one is 1/4 of the domain? Because there is from y equal to sine x to y equal to sine x by 4, there is horizontal stress. There is stress along x axis of scale factor 4. So y equal to sine x will enlarge along x-axis by 4 by scale factor 4. That's why if the domain of the enlarged graph is minus 2 pi by 2 plus 2 pi by 2 minus 2 pi 2 plus 2 pi, then the domain of y equal to sine x will be 1/4 of that. That's why we are considering this one. And the graph of y equal to sine x from minus 2 pi to minus pi by 2 to plus pi by 2, that is from this minimum point to maximum point. You see, that's why we know that the point of y equal to bx is the minimum point, because this one is this one. Okay, because sine x, from sine x, if you trace it along x-axis by scale factor 4, the graph of, you get the graph of y equal to sine x by 4. And that one becomes, this is 2 pi, that's the maximum. This is minus 2 pi, where the minimum of the, and there is vertical trace, that is trace. You see, if you look at Vx, there is vertical trace, there is vertical translation. So that's why we know this is the minimum point on the curve. Okay. Now we have completed the sketch of the graph of y equal to graph of gx on the diagram, and you have to explain whether the function g has an inverse. Of course, the function g has inverse because in this domain, the graph of gx is a one-to-one function. So we simply state, since gx y equal to gx, since gx is 1 to 1 function, so g has an inverse. Okay, that's it. That's the explanation. Now let's move on to part D. Part D has 6 marks. And here you have to describe fully a sequence of three transformations which can combine to transform the graph of y equal to sine x 0 to pi by 2 to the graph of y equal to fx, making clear the order in which the transformation are applied. So order and the sequence of three transformations. If you compare the curve, what is happening here? Y equal to sin x, you convert to, which has a domain of 0 to pi by 2 inclusive, and it will convert to y equal to fx, which is 3 plus 2 sine by 4, and the domain is 0 to 2 pi. Y equal to 3 plus 2 sine x by 4, and the domain is 0 to 2 pi inclusive. What are the changes here? If we think of general points here, this is xy, and here corresponding general point will change to what is happening here. There is a horizontal stress of a scale factor 4 because there is x by 4. Remember, horizontal stress of a scale factor 4 will occur when we have fx to y equal to f of x by a. That is horizontal stress of scale factor a. Horizontal stress means stress along the x-axis. And what happens when we have fx y equal to fx to y equal to a fx? This is stress of scale factor a along y-axis. So this will occur. And what is the another transformation here? Y equal to fx to y equal to a plus fx. That translation by 0 a or a unit along y-axis. So what is C? What is C here? There is one change along x-axis and two change along y-axis. The change along x-axis is it got multiplied by 4 for x, and along y-axis we have multiplication, then translation, that is addition. So if there are two transformations on y, which one comes first? On y, multiplication comes first, translation comes, addition comes second. But this is opposite in case of x. In x, translation comes first, then comes first. So in case of y, we do the multiplication first, multiply by 2, then you do the addition. Now it is clear. So it doesn't matter whether we do the trace horizontal first or vertical first, but the thing is, if there are two transformation along the same axis, then you have to be very careful about the sequence. Here we have to do the trace first, then translation. Trace first, then translation. Okay. Now let's write down the transformation in correct order. First we do what do we do? First we do translate horizontal trace along x-axis by scale factor 4 is along x-axis by scale factor 4. Then trace along y-axis by scale factor 2. Then the 3 is, third part is translation by 0, 3 or 3 units along X plus 3 units, that means most particular approach. Okay, that's part D. I hope it is clear to you. Otherwise, if it is not still not clear, then you can uh, go to the video on the transformation. Now let's move on to the next question. Next question, question number 9. Here you have the sum from the sequence. The second term of a geometric progression is 16 and the sum to infinity is 100. You have to find the possible values of the first term. So remember, for a GP, general term, nth term is a times r to the power n minus 1, and sum to infinity is a divided by 1 minus r. Here we know the second term. Second term will be a r to the power 2 minus 1, that's 1, ar, that is equal to 16. That's question 1. And the second condition is sum to infinity is 100. Remember, sum to infinity, a divided by 1 minus r is equal to 100. That's question 2. Now simply divide question 1 by question 2. That will give you ar divided by a by 1 minus r is 16 by 100. So we have ar into 1 minus r divided by a equal to 4 by 25. Now here a cancels out. We have 25r minus 25r square equal to 4. The 25r square minus 25r plus 4 equal to 0. So we have split one line here. In fact, we have taken all the term on the left-hand side, then divide by minus sign, we get this equation. Now solve this equation, which will give you, and you can use the middle term break, or you can use the direct formula to solve the quadratic equation. We are using the middle term break here. Since it is P1, you have to show the working. That's why we are showing a middle term break here. So we have two possible values of r here, 5r minus 4 equal to 0. So r equal to 4 by 5, or we have r equal to 1 by 5. If r is 4 by 5, then a is, remember, a is 16 by r, 16 by 4 by 5, it will be 20. If r is 1 by 5, is 16 by 1 by 5, that is 80. We have two possible values of a and r. But the question is asking for the first term, so the possible values are 20 and 80. Now let's move on to the next question, next part. In the next part, to show that of nth term of one of the two possible geometric series progression is equal to the 4 to the power n minus 2 multiplied by the nth term of the other progression. That is, the ratio of the nth term of the two progression will be 4 to the power n minus 2. So let's find the nth term of both progression first. So when in one of the progression A is 20, R is 4 by 5, then what will be the general term? Nth term A r to the power n minus 1, that is 20 to 4 by 5 to the power n minus 1. So if we separate it, we have 5 into 4 to the power n minus 1 into 5 to the power minus n plus 1, that is 1 minus n. So it is, if we simplify it, 4 to the power n minus 1 plus 1, that is 4 to the power n, 5 to the power 1 plus 1 minus 1, that is 5 to the power 2 minus n. And the next one, when a equal to 80, r equal to 1 by 5, the general term becomes a r to the power n minus 1, that is 80, 1 by 5 to the power n minus 1, that is, it is 16 into 5, that is 4 square into 5 into 5 to the power 1 minus n. So this is 4 square into 5 to the power 2 minus n. If you look at the power of 5, both equation, both expression has same power of 5, but in the first GP, where a equal to 20, the power of 4 is n, and the second GP, the general term has power 2 on 4. So there we can consider the first term has the higher value of the general term compared to the second term. So if you divide, let's name it the general term of the first sequence. If you divide this divided by the general term of the second sequence, to get the ratio, which is 4 to the power n minus 2. That's what you have to show here. That's part B. That's the ratio. One of the general term of one of the progression is 4 to the power n minus 2 multiplied by the general term of the other progression. That is, the ratio of these two is 4 to the power n minus 2. That's how show it. Okay, now let's move on to the next one. There is no further part in this question, I guess. So we are moving to question number 10. In question 10, we have the equation of a circle and the equation of a line. The line is tangent to the circle at the point P. P is unknown here, and there is another unknown in the equation of the circle. We have to show that the one possible value of A is 4, find the other possible value. Okay. Since the line is a tangent to the circle, if we want to find the point of intersection, we'll simply substitute the equation of the line on the circle. Let's do it then. So we substitute the equation of the line on the equation of the circle. We have x minus a whole square plus x by 2 plus 6 minus 3 square equal to 20. Now expand it. Before expanding, let's further simplify it. X minus a whole square. This is x by 2 plus 3 whole square equal to 20. Now expand it. X square minus 2ax plus a square. And here we have x square by 4 plus 2 into x by 2 into 3. That's 5x plus 9 minus 20. So this is 5 by 4 x square. Then we have p minus 2a times x, and the constant is a square minus 11. Now, since the line is tangent to the circle, this equation will have equal roots. So, the equation will have equal roots. That's why b square minus 4ac for this equation is equal to 0. Why? Because the line is a tangent. Line is a tangent to circle. That's why there will be equal. Now, this, if we apply b square minus 4ac equal to 0, b is here 3 minus 2a, a is 5 by 4, c is a square minus 11. This is equal to 0. So we have expanded, we have 9 minus 12a plus 4a square minus 5a square. Minus 5a square. Then we have plus 55. So the equation is minus a square minus 12a plus 54 a square plus 16a minus 64 equal to 0. Now you have to solve this quadratic equation. Remember, we are doing P1, so you have to show the working here. You can use the direct formula, although I'm using here the middle term break. So 16a minus 4a. I'm not explaining the middle term break here, so I guess you can do it. I'm doing it directly. A minus 4 into a plus 16. These are the two possible values. So a is 4 minus 16. So you have to show a is 4 and the other value is minus 16. That's it. That's part A. Now, let's move on to the next part. In the next part, for A equal to 4, find the equation of normal to the circle at P. If A is 4, we need to find the point of intersection. So the coordinate of P first. When A equal to 4, then the equation becomes equation 5 by 4x square plus 3 minus 2a x plus a square minus 11 equal to 0. Equation becomes 5 by 4 x square plus 3 minus 2a, this 3 minus 8 minus 5a plus a square 16 minus 11, that's 5. So if we divide by 5 and multiply by 4, we have the equation like this. And if we do the completing square here, we have x minus 2 whole square. So x equal to 2. Once you know the value of x, 2, then find the y coordinate. Use the equation of the tangent half x plus 6. Half into 2 plus 6, that's 7. So the coordinate of P is 2 times 7. Now the tangent, remember the tangent as the gradient. Equation of the tangent is the gradient of tangent at P is half. Therefore, gradient of normal will be minus perpendicular to it, the negative reciprocal of the gradient of the tangent. And this one passes through the point 2, 7. So equation of normal will be y minus 7 equal to minus 2 into x minus 2. So y equal to minus 2x plus 4 plus 7 plus 11. That's the equation of the normal at the point P to the circle. Okay, and the next part for a equal to 4, find the equation of the two tangents to the circle, which are parallel to the normal found in B. Okay, for a equal to 4, find the equation of the two tangents to the circle, which are parallel to the normal found in. So the gradient of the tangent is minus 2. Okay, here, if you draw here, you see, the question is a bit complicated. If you draw a rough diagram here, draw a rough circle, okay, and the equation of the tangent y equal to half x plus 6, let's say this is the tangent, this is the point P, and, and the normal is here. Remember the normal passes to the center of the circle. We have to find the equation of tangent, which is parallel to this normal. So the tangent, so these are the two tangents which will be parallel to this normal. Now we have to find the equation of these two tangents. Now what you see, we need the equation of center of the circle. Remember the equation of the circle is x minus a whole square plus y minus b whole square equal to 20. A is 4, so equation of circle x minus 4 whole square y minus 2 whole square equal to y minus 3 whole square equal to 20. So let's say this is the center, coordinate is 4, P. P is somewhere on the left hand side. I think P should be here. Is here. Now, if we can find the coordinate of these 2 points, then gradient of these two tangents is minus 2. Gradient of normal minus 2. And equation of this tangent y equal to half x plus 6. So here, since a equal to 4, the equation of the tangent, you have to find the equation of the tangent, two tangents to the circle which are parallel to the normal. We have roughly drawn the equation of tangent with a then point P, then the normal, which is gradient of -2, and the two tangents drawn in green color are the tangent. We have to find the equation of these two. Now, you see, to find the points at which these two tangents meet the circle, you need to find the equation of the diameter passing through the center and passing through this. This diameter has the gradient of which is parallel to the tangent, gradient of half and passes through or 3. Then the point of intersection of this diameter, let's say R and S, then we'll solve this diameter, equation of the diameter and the circle to find the coordinate of the point R and S. Then using R and S and the gradient of these two tangents equal to -2, we'll find the equation of the two tangents. Now, let's equation SR y minus b equal to half into x minus 4. So, which is y equal to x by 2 minus 2 plus 3, that's plus 1. Now, substitute it in the equation of the circle. We have x minus 4 whole square plus x by 2 plus 1 minus 3 square equals 20. Now, expand it. X square minus 8x plus 16. That is x square by 4. Uh, 2 into x by 2 minus 2 into x by 2 into 2, that's 2x plus 4 equal to 20. So we have 5x squared by 4 minus 10x equal to 0. So x, if you take x common, 5x by 4 minus 10 equal to 0. So we have two value of x. X is 0. The other one is 10 divided by 5 by 4. So that's 8. If x is 0, y is 1, and when x is 0, when x is 8, y is 5. So S coordinate of S is 0, 1, coordinate of R is 8, 5. So the equation of tangent at S is y equal to -2, oops, my bad, tangent at S0, y minus 1 minus 2 into x minus 0. So y equal to -2x plus 1, and here y minus 5 plus 2 into x minus 8. So y equal to -2x plus 21. These are the equation of the two tangents at the points which are parallel to the normal at P. Okay, that's it. Let's move on to the next question. This question is, the curve has equation y equal to k square root of 4x plus 1 minus x plus 5, where k is a positive constant. You have to find dy by dx. Okay, to find the dy by dx, let's first write y, the power form, k times 4x plus 1 whole to the power half minus x plus 5. So dy by dx is k into half, that's k by 2, 4x plus 1 equal to the half minus 1, that's minus half, into 4, that's the coefficient of 4x plus 1, minus differentiation of x, 1, plus differentiation of 5, which is 0. We are not writing 0 here. So it will be how much? 2k 4x plus 1 whole to the power minus half minus 1. That's dy by dx. Okay. In the next part, find the coordinate of the stationary point in terms of k. So to find the coordinate of the stationary point, remember dy by dx equal to 0. So dy by dx is 2k divided by 4x plus 1 equal to the power half minus 1 equal to 0. So we have 2k divided by square root of 4x plus 1 equal to 1. So square root of 4x plus 1 equal to 2k. 4x plus 1 equal to 4k square. So x is 4k square minus 1 by 4. That's the x coordinate of the stationary point. Okay, let's move on to the next part. Given that k equals to 10.5 and the equation of normal to the curve at the point, but the tangent to the curve makes an angle of tan inverse 2 with the positive. Tangent makes an angle of tan inverse 2 with the positive. Okay, so gradient of tangent is tan of tan inverse 2. Since the tangent makes an angle of tan inverse 2 with the positive x-axis, so gradient is tan of that angle which it makes with the positive x-axis. The gradient of the tangent is 2. Now you have to find the equation of normal at the point where the curve makes an angle of tan. Curve makes an angle of the, the tangent to the curve makes an angle of tan inverse with the okay. Now you have to find the point where the gradient to the curve, the gradient of tangent to the curve is 2 on the okay. So now we need the equation of dy by dx. Gradient of tangent is 2. So gradient of the curve at that point is 2. Now gradient of gradient of the curve is k by remember k by the root of 4x plus 1 minus. This is equal to 2 and k is 10.5. So k 10.5 4x plus 1 equal to 3. So square root of 4x plus 1, that's 10.5 divided by 3, that's 3.5. So 4x plus 1 is 49 by 4. 4x equal to 45 by 4. X equal to 15 by 4. 45 by 60. That's x coordinate of the point where the tangent makes an angle of tan inverse 2 with the curve. What is the gradient of the curve? Oh, no. Gradient of the curve was 2k. So this is 2k. My bad. 21, 27, 49, 48. That's 12. X is 12. Then what about Y? Y is a 10.5. The root of 4 into 12 plus 1 minus 12 plus 5. So what this is, that is 66.5. And then equation, you have to find the equation of normal. Now, the gradient of the normal is negative reciprocal of the gradient of the tangent, and it passes through 12, 66.5. So equation of normal is y minus 66.5 minus half x minus 12 plus twice y minus 66.5 times 2 is 136 minus x plus 12. So the equation becomes x plus 2y minus 145 equal to 0. That's the equation of normal at the point where the tangent makes an angle of tan inverse 2 with the positive x. That's the 11th C, and that is the end of this paper. Thank you.